Okay, so we're going to start with skill 12 today. Like I said, it is going to have to do with end behavior, which is part of what we're going to talk about. It also involves zeros and factors and factoring. So really, it's kind of, I mean, there's some new stuff in it, but it's a lot of review and it's a lot of putting a bunch of pieces together. And I hope that you enjoy that a little bit. So we're going to work with these columns. So you can see the first column we've got is linear factors, and then the second column we've got is zeros. So we're going to work with those two things, and it's almost like a compare and contrast. We're going to talk about what the different things are. So for linear factors, what they are that they are pieces whose product is a polynomial. So factors of a polynomial. Oh, I don't know why my thing is jumping around like that. Sorry, guys. Okay. Zeros, values of x when y equals 0. Values of x when y equals 0. What do linear, notice the word linear. What do linear factors look like? So when you hear linear factors, you should be thinking that you only have an exponent of 1, and so you just have x's. And so when you talk about linear factors would look like x, or x plus 7, or x minus 3. That's what your linear factors are going to look like. What do your zeros look like? X equals some number. So we're going to just put a in there, some number. How do you find factors? We have been doing this for forever. What's the first thing you look for? GCF. Okay? And then you look to see if you can factor anything. So GCF and factor. How do you find your zeros? Again, have we talked about zeros? Sure, we have. Zeros are zeros, they are solutions, they are x-intercepts, they are all of those things. So how do you find them? You set your factors equal to 0. Set your factors equal to 0. So factors are 2x minus 1 and x. What are the zeros that match that? You would have 2x minus 1 equals 0. If you solve that equation, you get an x equals 0. They're actual solutions. This one, just x equals 0. This one, you'd have to work backwards. If you know your answer is x minus 7, what would have gotten you that? And that would be x plus 7. When you set that equals 0, it would move over and you get your answer. Okay? Identifying the zeros if given a graph. This should be really easy. We've talked about this before. What are zeros the same as? Zeros are x-intercepts. So if they're asking you for the zeros, you just look at your graph. X equals negative 3, x equals 1, and x equals 4. What do these all have in common? The y is equal to 0. That's what they have in common. So what are your zeros here? X equals negative 2, x equals 1, and x equals 3. X equals negative 2, x equals negative 1, and x equals positive 1. Those are the zeros. Again, that's a concept we've talked about. Zeros are the same as your x-intercepts. X-intercepts are the same as zeros. That's going to play a big part in today's lesson as we keep going. Okay? So you've got that hopefully figured out. That wasn't too hard. Identifying zeros if given a function. We defined this in the chart a couple minutes ago. If you're finding the zeros of a function, you are letting y equal 0. Okay, and so you just have to let 0 replace this h of x, or let it replace the y value. So here's the question. Prove that x equals 2 is a 0. Well, how would you do that? What you're asking is, does h of 2, right, you're going to plug in 2 for x, does h of 2 equal 0. That's what you need to check. Well, let's go ahead and try it. H of 2 is equal to 2 squared plus 2 minus 6. 4 plus 2 minus 6. 4 plus 2 is 6 minus 6. Well, does 6 minus 6 equal the 0 we're looking for? Sure it does. So does it work? Absolutely. It totally works. Okay? It is extremely easy to find the zeros of a function if you know what its factors are. So when you have an equation that's in factored form, you don't have to do any work. You set each factor equal to 0. Have we done this before? Yeah, a bunch of times. Set each factor equal to 0. So the question I usually ask you guys, if you look at this problem, how many factors do you have? I hope you're saying 4. There are 4 factors. So how many solutions are you going to have? You're going to have 4. So to find your answer, you're going to do 4x equals 0. You're going to do x minus 1 equals 0, x plus 8 equals 0, and x minus 3 equals 0. You have 4 mini equations to solve. Divide by 4, x equals 0. Add your 1, x equals 1. Subtract your 8, x equals negative 8. And add your 3, x equals 3. So 0, 1, negative 8, and 3. Okay. Let's talk about this next one, and I'm interested to hear your answers. It is a little bit trickier than the one we just did, so think carefully about your answer. It says identify the zeros of the function. So what I want you to think about first is, what are your factors? Okay, so factors have to be linear factors. So how many factors do you have? My guess is most of you are saying 3. That's not right, but I'm guessing that's what you're thinking. Remember, your factors have to be linear. Well, look at this first part. Is x squared linear? Well, no, it's not. So how do you get x squared to become linear? Well, what does x squared mean? It means x times x. So when you talk about your factors, it's really x times 3x plus 1 times x minus 5. So how many factors do you have? 1, 2, 3, 4. You actually have 4 factors. Set them equal to 0. X equals 0, x equals 0, 3x plus 1 equals 0, and x minus 5 equals 0. So these don't need to be solved. They already are. X equals a negative 1/3, and x equals a positive 5. So you had 4 factors. You have 4 solutions. I want you just to look at the fact that you have x equals 0 and x equals 0, that you have it written there twice. That's going to come into play later on in the notes today, and we're going to talk about what this actually means, the fact that you have 2 of them. It's called multiplicity. Using the zeros of a polynomial to sketch the graph. Okay. So you've got a couple of things that are going on here. You're going to have to work with end behavior based on degrees. You're going to have to work about degrees and direction, and you're going to have to use x-intercepts. So let's go ahead and talk about number 1. You're going to graph the zeros. Okay. Number 2, you're going to plot points between the zeros. You don't know where those points are yet, so you're probably going to have to find them. You're going to have to plug in x values to find them. Number 3, and this is what we were just talking about, you're going to have to check end behavior. So that's that chart. Is it up, up? Is it down, down? Is it up, down? Or is it down, up? So you have to check that. And then you're going to be able to go ahead and draw it. All right, so let's go ahead and do zeros. X plus 2 equals 0, x minus 1 equals 0, and x minus 3 equals 0. So x equals negative 2, x equals 1, and x equals 3. So you have negative 2, 1, and 3. So you're going to pick x values between those. It doesn't matter what you pick as long as it's in the middle. So let's pick x equals 0, and then what's in between 1 and 3 is 2. So x equals 2. So those are the things that you're plugging in. Y equals 0 plus 2, 0 minus 1, and 0 minus 3. So y equals 2 times negative 1 times negative 3. So when you do that work, you get y equals 6. If you're talking ordered pair, it's 0, 6. So 0, 6. There. Do the same thing, except this time you're going to plug in 2. Y equals 2 plus 2, 2 minus 1, and 2 minus 3. So y is equal to 4 times 1 times negative 1. So y is equal to negative 4. So your ordered pair is 2, negative 4. 2, negative 4. Okay. Let's talk end behavior. That's going to be a little bit more for you to think about. Go back to the original. If you look at just your variables, you have x times x times x. So x times x times x. You have a third degree, and there's nothing here as a coefficient. So if you're talking your end behavior, if you're talking about your sled, leading coefficient is positive. You don't have anything in front of your parentheses. End behavior, you have an odd value because you have a degree of 3. So when you picture positive and odd, it's going to start down and end up. So go on here and graph that. Down, up. That's a degree of 3, right? 1, 2, and then 3. So you have 3 directions on there. Let's do it again, but change it a little bit, of course. So let's find our zeros. X equals 0. X minus 1 equals 0. X plus 2 equals 0. And x plus 3 equals 0. So x equals 0. X equals 1. X equals negative 2. And x equals negative 3. Okay, so let's start. What is in between negative 3 and negative 2? So x equals negative 2.5 is really what you should be plugging in. Y equals negative 2.5 times negative 2.5 minus 1 times negative 2.5 plus 2 and negative 2.5 plus 3. Negative 2.5. If you do negative 2.5 minus 1, you're at negative 3.5. If you do negative 2.5 plus 2, you're going to be at negative 0.5. And then negative 2.5 plus 3 is a positive 0.5. You would get out your calculators, do all that multiplication, and you end up at negative 2.1875. Negative 2.5 comma negative 2.1875. That's your first ordered pair. Okay, now you have to go between 0 and 1. So you have to do